Welcome back. It's your boy, Joe Lane Sensei, Mr. Lane, Matua Joe, all those exciting things. If you are here, you're watching the 1.4 2024 derived grade exam answers. If you haven't seen the last ones, go back and watch that. Enough of that faff. Welcome to question 1B. We're going to get stuck in. Let's have a look at what we got going. Right. Different size circles are shown below. Beautiful. We don't care about this sentence. It is unimportant. Circle A has a diameter of 18 centimeters. That's also listed here. Circle B has a diameter of 12 centimeters. That's listed here. Diagram is not to scale. Cool. So this is all of the information that we've got about the diagram in front of us. Let's look at this. ABC is a right-angled triangle. So it's not like the question before. We already know that for certain this is right-angled. Okay, beautiful. The question that we actually need to answer is find the diameter of the smallest circle. So what we care about is the distance from here to here. What is that value? Actually, we also care about the distance from here to here. What is that value? Turns out they're both exactly the same distance because at the end of the day, what we're trying to figure out is the distance all the way across the circle. And if we can figure out what those two lines are, we can figure out what the entire distance across there is, right? If we can find the radius of a circle, we can find the diameter of a circle. Similarly, if we can find the diameter of a circle, we can also find the radius of that same circle. So what's the radius going to be? This green line that I've drawn just here, what's the radius going to be? I'm going to give you a few seconds to think about it. It's going to be half of that. Correct. It's going to be 9 centimeters along this line. And what about this one? Well, this one is going to be half of 12, which is going to be 6 centimeters. And we've actually already figured out the length of these two lines as well. We've got 6 centimeters here and 9 centimeters here. So now we've got a whole bunch of information that's figured out. We know that this is a right-angled triangle. I'm going to put my little black line back here. We know that it's a right-angled triangle. So just like the last time, I can use Pythagoras' theorem to set this up again. I'm going to put Pythagoras' theorem in blue. I'm going to put it right here. I'm going to say a squared plus b squared equals c squared. And actually, I'm just going to move this over to the right a little bit because I happen to know I'm going to work in the middle of the page. Beautiful. So I've got all of this information. Ooh, go away. I've got all this information that I know. So let's start by thinking about what is our value of c going to be? What is this value going to be? C is always the longest line of our triangle. It's always the longest line of our triangle. So in this case, I know that C is going to be 9 plus 6, right? I know that that's going to be 9 plus 6 because I know that this long line is that distance right there. Okay, great. What about, I'll put my green line back there. Sorry, I erased it for you. What about the length of our line A? Well, it doesn't matter whether we choose this line or this line to be A, so I'm just going to start with this one, okay? I know that that value is going to be 9 plus x, right? Just like I know that this one is 9 plus 6, I know that this one is 9 plus x. Okay, so I'm going to try and find out what my value for b is. I'll put a right here, I'll put b right here, and I'll put c right there. What's my value for c going to be? Give you a few more seconds to think about it. That's right, 6 plus x squared. So I always want to make sure that I can do all of the operations possible before I start working with variables, right? This right here, actually, before I go on to that, you should know that if you do this, you've got achieved. Already, you've got achieved. You set up the quadratic formula, so you get achieved. Well done. This is an excellence level question, but if you get this far, you have done achieved. And this is why I always say, try every problem. Even if you don't quite know what's going on, write some things down because you never know if you're going to get credit for what you've done. Okay? Right. So let's go on to the next step. As I say, we want to do all of the operations we possibly can before we move on. Okay? So in this case, I can do all of the stuff that's right here. Yeah? 9 plus 6 is pretty easy. 9 plus 6 is going to give us 15 squared, and everything else here is going to stay exactly the same, right? I'm not changing anything over here, so I'm just going to copy it all out. Now we need to know what 15 squared is. Now, you are, a year 11, struggling through this world. You don't know what it looks like to be an adult, So maybe you can't do 15 squared in your head, but I can. I know that it is 225. Yeah, but you don't. You can use a calculator, so don't worry about it anyways. Chuck that into your calculator, and Bob's your uncle, right? Squared plus 6 plus x squared. So at this point, I haven't done anything to this side of the equation, right? Nothing has happened over here, and that's fine. That is absolutely fine, but it is time that we have to start dealing with it. And the first thing that we need to do is expand. I'm going to move over to the side here, a little bit of extra paper, and I'm just going to put my 9 plus x squared, 9 plus, let me erase that, 9 plus x squared over here, and let's see what it looks like when it's expanded. We are going to have to use FOIL to do this. First, outside, insides last. But there aren't any firsts, there aren't any insides, and there aren't any lasts, and blah, blah, blah. We don't like it. But all we have to do is express it in a slightly different way. 9 plus x, just like that. Yeah? And you'll have seen this before. This may be a little bit confusing to you, but just remember, if you've got 4 squared, that's the same as doing 4 times 4. And if you've got 17 squared, that's the same as doing 17 times 17. If you've got n squared, that's the same as doing n times n. And similarly, if I have 9 plus x squared, that's the same as doing 9 plus x times 9 plus x. So we're just writing it out in a different format to the way that it looks. And then we can do first, outside, inside, last. So my firsts are 9 and 9. I'm going to get 81 from multiplying those two together, plus 9 times x. I've got my outsides, 9 times x, and that's going to be 9x, plus x times 9, because I've got my insides, 9x, plus x squared. So this is what we get. Now, just with every quadratic, you can now collect your like terms, right? So these two guys right here, they're going to be able to go together. This fella, he's an awkward extra. This chick, she's out there doing something different. But these two in the center, they can go together. So if I have 9 x's and I add 9 more x's to it, what do I get? That's right, 18x plus x squared. Gorgeous. Okay, so that's what we're doing in this space. So this information right here, I am going to get it. Let's see if I can grab all that. Oh, did I grab all? No, I'm missing a squared. Oh, the magic. And then I am going to copy this, and then I'm going to paste it back over here. Paste. Oops. And I could put that right underneath where my, let me move it? No, it's not letting me move it. There we go. I can paste that right here. Yeah, because we have seen that those two things are exactly the same. Actually, I'll use a highlighter. This bit right here is the same as this bit right here. We showed that on the working on to the right. Similarly, we can do exactly the same thing for 6x squared. 6 plus x all squared. Now I'm going to do it without the explanation because I have faith that you would be able to do it as well. Okay, so all we have to do, 6 plus x times 6 plus x, and then you could do your first, outside, inside, last, and you could just trust me that it's going to come out to that. Okay, if you want to, you can work it out yourself as well, though. All right, so let's have a look and see. Now that we've gotten to this point, you, by the way, right here, this is a merit level question. So if you got here, you've gotten merit. Yeah, well done. Now we're just looking for the excellence from this question. Okay, we want to successfully uh, narrow this down a little bit. So we've got some like terms. Let's put some highlights in our like terms. We've got an x squared and an x squared here. That's good to see. We've got an x here and an x here. Those are like terms as well. And we've got our 81 and our 36. So all of those are going to go together for us. Okay? So when I've got two x squareds, I could write 2x squared. Yeah? And then I will have successfully, and I'll do this real lightly, cross these two out. Okay? And then I can do my x's. 12 plus 18 is 30x. Beautiful. I've crossed this one out, and I've crossed this one out. Okay? And then 81 plus 36. 81 plus 36, that's 117. 117 equals 225. We still have a ways to go, though. I'm sorry to say it, we still have a ways to go. Yeah, we have to figure out what x is equal to, because remember, we are trying to find, oh my gosh, how did all of this move so much? I don't know where it went when I was, I must have been doing something wrong. Oh, it's all working out wrong. Let's clean some of this up. I'm sorry, this is what happens when you're a professional teacher instead of a professional screen capturer, you know? We'll get rid of some of this. You can scroll back to the beginning to find out if you needed this information. Yeah, right. Remember that we are trying to find the diameter of the smallest circle. We are trying to find this value right here. Yeah, we're trying to find the value. So we have to find out what x is. We have to find out what x is. Okay. Well, I know that I want a quadratic equation to be in the format x squared, a plus x squared plus bx plus c equals 0. It's really, really important that I get everything equal to 0 or else I can't figure out what my x is. So let's have a go and see if we can do that. We'll do that by subtracting 225 from both sides. What's the result of that going to be? Nothing's going to change here. Nothing's going to change here. Something's going to change there, and this will go to 0, right? We're going to get minus 108. So that value right there is going to be minus 108. All of this pretty straightforward. Now, if we want to factorize, we have this format. We want to put it back into a format that looks like what we started with. We want to put it into something that looks like that. So we've got to figure out how to do this. The big thing is, I can see that this value right here, again, I'll change my color. Oops, don't want to do it that way. I'll change my color. This value right here can be factorized from all of the other values. The coefficient 2 can go into all of the other things, right? So I can actually pull that out. I'm going to put 2 on the outside, and I'm going to have x squared plus 2 times what gives me 30x? 2 times what gives me 30x? It's going to be 15x. And 2 times what gives me a negative 108? That's going to be negative 54. So we're looking at our final steps here. We want something that is going to give us, and I use the magic X method. I'll put a link to the wonderful woman who describes this so well. I use the magic X method. We want something that multiplies up to negative 54 and adds to 15. Oops, that didn't go the way I thought it was going to. Adds to 15. What multiplies up to negative 54 and adds to 15? Well, let's look at our factors of 54. We have, obviously, 54 and 1. Yeah, no problems there. We've got 2 and 20. 7. Okay, can we get 3 in there? Yeah, we can divide that by 3. We can divide by that by 3, and that is going to be 18. Can we get 4 in there? No, we can't. 5 won't do it. 6 probably will. What's 6 going to be? 9 and 7 won't go in, and we're kind of back at the beginning. So these are all of the factors of 54. We want to find something that multiplies up to negative 54 and adds to 15. Well, that's going to be these two values right here, right? If I had 18 and negative 3, I would be able to multiply those two together to get 54, and I'd be able to add them together to get 15. So when I factorize this, I'm going to know that it's 2 times x plus 18, x minus 3 equals 0. Does that make sense? If I was to do FOIL on the values inside these two brackets, then I would come out with the value inside this bracket. Okay? But that doesn't actually tell us what x is equal to. What x is equal to. So what is x equal to? If I want this whole thing to be equal to 0, I'm going to find out that x is equal to either negative 18 or 3. Negative 18 or 3. Okay? This right here can't be right. We can't have negative 18 because a circle can't have a negative diameter. We're not traveling into the 4th dimension. That's not part of what we're doing here. So we know that x has to only be 3. Which means, what is our diameter? If our radius is equal to 3 centimeters, what's our diameter? 6 centimeters. Now, obviously, this would be down the bottom, but somehow my movements got messed up. This, if you got this answer, you have gotten an excellence grade. Okay? So this is how you'd go about getting excellence on this question. It took me 17 minutes to explain how to get there. You should be able to do it a little bit more quickly because you won't have to be talking to an audience and explaining everything. But good work. Go watch the next video. I'm proud of you. Keep up the math work.